Good morning, my YouTube viewers. Crystal here. I'm just here this morning with Google Colab, and I wanted to go over this program that I have written with you because I had done a tutorial with Simply Learn, and we had imported 1,000 companies, and we were endeavoring to um, use linear regression on those 1,000 companies. And as I was going through the tutorial, the code didn't work. And because the code didn't work, I wasn't able to finish the tutorial. And I found that to be quite upsetting. That happens to me a lot. I do tutorials. I even took an IBM course, and the code in the IBM course didn't work. And I ended up spending a lot of time trying to troubleshoot the code to find out what the problem was, why the code wouldn't work. And so although I was getting experience troubleshooting, and I was actually learning about Python and learning about the computer programs while I was troubleshooting the code, I was wasting a lot of time as well. And because this code didn't work, I spent about a day trying to get the code to work, which I couldn't get it to work. And they were using very complicated coding, which I don't think that they should have been doing. I think they should have kept their coding as simple as possible, because people who are doing the tutorials are doing it because they want to learn, and they're not going to learn anything if the coding is so elaborate that it's not going to work. So what I had to do was I had to research coding on my own, and I found an article entitled 6-Line Linear Regression, and the article was how you can linear regress something in only 6 lines of code. So I used that code, which I actually got to work amazingly. And they said that, well, you can use this code. If you want to use this code on more than one variable, you can just research sklearn. So after I got that one code to work, then I was researching sklearn, and I found some more tutorials just on sklearn on how to get a multivariable file to work with linear regression, and I was able to get that to work. And so I decided, well, let's go ahead and use what I've learned about linear regression, about single linear regression and multiple linear regression, and input this file that I had been using with sklearn, and go through this program and see if we can get it to work. So the first thing I did was, now the file is longer than 6 lines, but it started out as 6 lines, and it started out as a single linear regression, and then I wanted to make it a multiple linear regression. So what I did was, just as a matter of course, I always input the bulk of the files, because you never know which ones you're going to need. The second thing I did was I imported some more libraries, and I just, as a matter of course, I input the bulk of the libraries, because you never know which ones you're going to need. I mean, obviously, I don't need all of these libraries because it's a very simple program, but I just end up importing all of the libraries anyway, because you never know as you begin your programming which ones you're going to need. The one that we're going to be using in this example is linear regression, which is towards the bottom. The next thing that I did was I imported my data set, and you can see that I got this 1,000 companies file off of GitHub. And so you can download the file too if you want to follow along with me. I printed off the data frame by using the companies, just typing companies, and you can see it's got 5 columns and 1,000 rows, which it tells you right here towards the bottom. The next thing I did was I wanted to find out a little bit about this file. And as you can see, it's got 5 rows, or 5 columns, and it does have 1,000 rows. And as you can see that in the file, and you can see that all of the files are float except for the state column, which is an object. The next thing I did was I wanted to put a pivot table in there just to make a representation of how much profit is awarded to each state. So there were 3 states that these Clausen companies had data recorded on them, and it was California, Florida, and New York. And you can see that California had the most profit of the 3 companies. The next thing I did was I did a plot, a seaborne disk plot on the profit to see where the profit lies. And the profit mainly lied in the, 100,000 to 200,000 region. The next thing I did was I plotted a graph of how the research and development relates to the profit, and you can see the plot right here. The next thing I did was I did a plot on how the administration fits in with the profit, and you can see the plot right there. And the next thing I did was I did a plot on how marketing relates to profit, and you can see the plot right there. So research and development had the most linear expression of how it relates to profit, but marketing spend, it came in second, and administration came in third. So if you were going to analyze only one variable, then research and development would be most likely the variable that you were going to analyze, because it would give you the most accuracy. And if you were going to analyze 2 variables, then it would be research development and marketing spend, because those 2 variables would give you the most accuracy. And then what I did was I gave you a heat map of the 3 variables along with the profit. And so you can see this representation in the heat map. The next thing I did was I defined my X and Y. So my X was the 3 variables: research and development spend, administration, and marketing spend. And my Y was profit. And so what I did was I wanted you to see what X looks like. So X is again what I just said. It's 1,000 rows with 3 columns. And you can see that data right here. X shape shows you that X is a 2-dimensional array of 1,000 rows and 3 columns. And then the next thing that I wanted to see was what is Y comprised of. And Y is comprised of profit. And it tells you right here that Y is profit of 1 column and 1,000 rows of data, and it's a float. And I wanted to see what Y looks like with the shape command. And it shows you that it's a 1-dimensional array of 1,000 rows. The next thing I did was the actual linear regression model, which tells you which is part of the 6-line linear regression model. So linear regressor equals linear regression. That's the function that you're going to be using from Python and sklearn. And then so linear regressor.fit X and Y. So that's going to perform the linear regression. And ypred equals linear regressor.predict X. And so that's the formula that's going to make your predictions. So I wanted to see what ypred looks like. So I did the ypred command, and I came up with all of these variables. This is your 1,000 predictions. So what you wanted to do is you wanted to see what your accuracy was. So we did linear regressor score, and it gave you approximately 95% accuracy. And so the next thing we did was we printed off the intercept, and we printed off the coefficients. So that concludes it for this program. I mean, I would have liked to have made it in accordance with more elaborate, but at the moment I don't know enough to make it more elaborate. But at some point, if I ever get the knowledge and the skill to make it more elaborate, i.e. using train test split methodology, I will. But it's very difficult to use train test split methodology on linear regression, and that's one thing that I found out through my investigation. But as I learn how to code these models, I will be making more videos. So I hope you get something out of this video that I've made for you. And obviously, you can follow along with me, and hopefully you'll learn a little bit about linear regression and how to code linear regression. And hopefully this will work, because you can see I've done it on Google Colab and it worked when I did it, which it didn't work when I tried to do it on Simply Learn. But Simply Learn is not the only company that provides coding that doesn't work, because as I said, I was doing a course on an IBM course, and their coding didn't work either. And then you would think that since IBM is such an impressive, massive company, that they would put forth a little bit of effort to make sure that their code works so their students can follow along with them, but they don't. So let me know what you think about this presentation. Let me know what you think about my coding. If you've got any comments, or you have any, or if you know how to implement X-train split function, then certainly let me know. If you like my video, please like, subscribe, and share. And if you want to support the work I'm doing, I have my email address for my PayPal account down below, and any donations that you send will be very greatly appreciated and used to fund my education and my expenses. So thank you very much for watching this video, and I hope to be getting more videos of this type out to you.